Just like with a capacitor, when you first switch a circuit containing an inductor on, it doesn't behave the way you might instinctively think it's going to behave. So let's imagine what happens when we first turn this circuit on and we get some current running through it. I hope you can see that down here with our inductor, it's a coil, and as soon as we start running the current through it, it's going to start building up a magnetic field. And it's not going to want to build up a magnetic field. It's going to resist the flux changing. So if the current was running through it in this direction, and it's running through the coil itself is going to build up a magnetic field that resists the change. Therefore, at the beginning, no current will flow. The inductor here will successfully resist having a current run through it, and therefore having a inductance, a magnetic field build up inside it. However, over time, that will change. Slowly, the current will start to flow faster and faster through it because the flux will be changing less and less rapidly, and therefore it will stop resisting that change so much. And so what we get is, at first, no current flowing, and over time, more and more current flowing until it reaches maximum current. Okay, and the maximum current that can flow in the circuit is obviously V over R, where R is this resistance here, because eventually, once enough time has passed and the circuit has built itself up, this will just act like a piece of wire. It's no longer changing its flux. That's the key point here. Of course, if there's no current flowing, then this is acting like it doesn't exist. There's no current flowing through it, and all the voltage is equal to, all the voltage across our inductor is equal to the supply voltage. But over time, that will drop. Okay, and our supply voltage, Vmax, is our supply voltage. So at first, just the opposite to how a capacitor worked. At first, there is no current flowing because the inductor is resisting the change in its magnetic field. Conversely, there's maximum voltage across it at that point. Over time, as the change in the magnetic field becomes less and less, the current will start to build up and the voltage across it will start to drop until eventually there's maximum current flowing and no voltage across the inductor. That doesn't mean there's no voltage in the circuit, it just means no voltage across the inductor. The inductor is acting just like an ordinary piece of wire eventually. And just like with capacitors, it has a time constant in which it does this, which is given by L, the inductance, divided by R, the amount of resistance in the circuit. And if you're interested in why that's the case, why it's L over R, we can work that out in class. But for now, I just want you to accept the time constant is determined by L, the size of the inductor, divided by R, the size of the resistance in the circuit.